Hi everyone, my name is Mohamed Najaaf. I work as a solutions architect at Amazon Web Services, and today I wanted to talk about how you can build generative AI applications at AWS sustainably. So I'm going to walk through some of the design considerations and what are the techniques you can adopt when you're building generative applications so that you can reduce your overall carbon emissions that are emitted by your GenAI applications. So I wanted to start the session by showing you some study based on the data available from Deloitte, Gartner, Goldman Sachs, and few other major companies around the world. And you might be already familiar or have heard of this energy spot that are being spiked all across the world due to this AI models, right? And we know that the AI models are getting bigger day after day, or each month we see a new releases of an LLM from leading companies all around the globe. And so on the left hand side, what is the model training size index? And from 2014 all the way to 2024, what we have seen is it has increased more than 350,000 times. And this is the spike originated in the year 2021, 2022, when the chat GPT started to make waves around the world and people started using more and more AI and curious about how they can integrate that into their own organizations and applications. And we've seen people building and training these models with vast amounts of data, right? And that takes a huge amount of energy from all across the world. And on the right hand side, what you can see is the total data center electricity demand from 2022 to 2030, and you can see that it has been quite steady since 2020, and then from 2022 it has started to spike all across the world. And what we are expecting to see by 2030 is almost 800 terawatt hours of electricity will be needed to power these data centers, powering the AI workloads. And we also have certain studies by Goldman Sachs Research, which they are forecasting that 60% of the increasing electricity demands from data centers will need to be met by burning fossil fuels. And that's not something that we encourage, or none of us want. And because this could increase the carbon emissions, the global carbon emissions, by approximately 220 million tons. And that's a huge amount. And another article from World Economic Forum says that the computational power required for AI is doubling approximately every 100 days. And these figures are quite staggering and shocking. And with the pace the AI is evolving, we need to be responsible when we are developing or creating generative workloads in our own organizations, right? And we need to think about how sustainably can we achieve this and get this business use case, right? And that's the main agenda for my session here, what and how AWS can help you with that. So one of the things I wanted to touch upon is how AWS can lower your carbon footprint by up to 99%, right? And this is by migrating your workload, which you may have on-prem, all the IT workloads that you have there, and by shifting into a energy efficient data center that AWS has all around the world. And Amazon had a climate pledge in 2019 to be 100% renewable resources in order to power our data centers. And we achieved this goal by 2023. And we are quite proud of that. And all of our data centers are powered using this 100% renewable resources. And we also integrate the efficiency at the hardware layer, at the cooling, the water that is being recycled to cool the servers and the machines that we have in the data centers, and the carbon-free energy that's being produced and used by the data centers, and all the managed services that we have at AWS is all optimized workloads. So when you're thinking about creating or developing a generative AI application, when you create that inside or within AWS, by default, you achieve that sustainability and you reduce your carbon footprint up to 99%, and that's a huge number. And I also want to touch about the managed services, right? So when you have migrated to, or when you're, if you're planning to create something with AWS, what we all recommend is start with the managed services or the serverless services that we have. The reason is simply because we take that undifferentiated heavy lifting for you, whether it's maintaining the hardware or the underlying networks or the security of the data center or the patching of the OS. So you don't have to worry about the underlying infrastructure. You can just focus on developing your application, setting the right configurations and the access, the IAM policies, those kind of stuff, where we focus on more of the basic, the heavy duty stuff for you. And we do that with sustainability, with cost efficiency and operational efficiency and everything in mind, right? So that's going to help you to achieve that sustainability in a longer run. And you may already have started using some of the services that you see on the screen, or might have already aware of the services such as EKS, which is our Elastic Kubernetes service, which is for Kubernetes orchestration. Amazon Bedrock is our fully managed serverless service where you can access 200 plus foundation models with the use of a single API. And Bedrock Agent Core is a newer service where you can build agentic systems, multi-agentic orchestrations that you want to implement at an enterprise scale. And SageMaker has been one of our popular AI/ML service where people have been utilizing to create train models and deploy models at scale as well. The takeaway is simple. When you have the option, when your organization policies allows, always go for the managed and serverless services to give you that to remove that undifferentiated heavy lifting and the operational burdens that you do not want to. And we take that chunk from you where you can focus on your more important application related tasks. And the next important factor is model selection, right? And we know that lots and lots of models are coming up every month. And so whenever you are creating an application, you start with a particular model, but later down the line, you will see that the same provider has an updated model. So this is a frequent process, right? That regularly you will have to evaluate your model and decide, does that meet your criteria, your business use case, the latency or the hallucination or a bunch of evaluation criteria that your organization has? And once only it passes, then you make that change internally. So there are different criteria that each individual company takes into consideration, such as multilingual capabilities. Does it need to speak any other language than, or generate text in any other language other than English? Or does it needs to be a proprietary model or an open source model? Or which size, the number of parameters and corpus size? Or does it need to be a generalist model, or do we need to make it a domain specific if you need to be more integrated with financial services terms or healthcare domain? Do we need to fine tune it? So these are some of the questions that people ask when selecting the model. And what we see is that you often don't need the biggest and the most intelligent LLM to power your applications. For example, you might not need a Claude Opus 4.6, which is the latest one that they released recently. But your business use case might be achieved by using a Claude Haiku for 4.5 instead, right? So when you use a much lighter model, that means first of all, you're not spending much. It is a much cheaper model. At the same time, it doesn't need that many resources to get that inference, which in turn means it doesn't require that much energy. So when you're using a lighter weight model, most of the time it says you are consuming lesser energy compared to a larger model. So selecting a model which is at the lightweight is an important factor. And next one is about evaluations, and we have the Amazon Bedrock evaluations where you can evaluate your models, and also if you have knowledge bases and you want to evaluate against a different set of models and parameters such as helpfulness, faithfulness, correctness, all the way to harmfulness and refusal. Those are some of the parameters that we have. And if you also have certain custom evaluation metrics, you can also integrate that into this to identify which model is the best option for you. And the other aspect is the model customization and adaptation. So what we have seen is when we are building generative AI, GenAI applications, we often try to tweak the prompts in order to achieve a specific output that we want. So at the bottom of the screen, you can see is the prompt engineering. And this is the easiest and the most energy efficient way to get customize a model. And we know that sometimes for specific use cases it might always not work the best way, and that's why we have a bunch of other options as well, right? Such as retrieval, augmented generation. This is where you connect to your own proprietary internal data and you have a vector store, so that when you are generating the text, it always fetches the data from your internal data to reduce the hallucination. It also gives you more accurate data, like a customer's data based on your organization informations. And then we have the fine tuning, and then we have the full fine tuning as well as parameter efficient fine tuning (PEFT), which is basically a way to fully tune the model so that we keep it a subset of labeled data sets, and we are teaching the foundation, the LLM, to give a much better results. That's something that we are looking at, right? So basically teaching the foundation model. And the parameter efficient fine tuning is where you only tweaks a subset of parameters, not the entire parameters. But in full fine tuning, you does the full parameter customization. So those are like some of the options that you have there. And lastly, we have the training from scratch, which only very small number of customers globally does, because it's really expensive to train something from scratch, and the amount of data that's needed is also much greater. And it also is the highest energy consuming and the highest carbon emitting in a process, right? And this is something that nobody wants to do, but only very few use cases will need to explore that approach as well. And choosing the right silicon is really important. If you're going for a service where you are training your model your own, and you want to select the right infrastructure, the right virtual machine in order to train the models, and we give you a couple of options there, right? And that is Trainium instances. Trainium are custom Amazon built silicon chips, which gives you up to 25% more energy efficient than comparable EC2 instances, right? So there is no question that is more sustainable and much better performing as well. And we have the Trainium 2 instances, the next generation, which offers 3 times more energy efficient than Trainium 1. And I'm also happy to say that it's not included in the slide, but we just released in the last reInvent that we have Trainium 3 instances, which are 4 times more energy efficient and performing than the previous Trainium 2. So it's just getting better and better. So whenever you are thinking about model training, we advise you to make use of the silicon chips to get that better price performance as well as sustainability and reduction in the carbon emissions. And if you also have inference workloads, there is also an option to use your non-GPU chips as well, and that's where Graviton comes into play, and it again gives you a much better price performance when compared to its Amazon EC2 alternatives, and it also takes up to 60% less energy compared to an EC2 instances as well. So these are some of the hardware options that give you, right, and how you can reduce and make your applications more sustainable. And next, I wanted to talk about the model deployment inference optimization. So these are the different boxes that you see here are some of the techniques that you can use to reduce the overall model size and optimize memory usage. So when you're reducing your model size or when you're optimizing memory usage, you are only using the most required amount of resource and energy, right? So it is very important that you consider these different techniques when you build such AI applications. We have model compilation, which is optimizing models for hardware. We have model compression, which is reducing model size very efficiently, and all the way to distillation. And this is where we have a larger model such as Cloud Opus 4.6, and we have a smaller model like a student model where it teaches all its learnings to the underlying model. And the idea is to let the smaller model handle most of the queries efficiently and with almost the same accuracy as or intelligence of the Cloud Opus. So these are like some of the techniques we can explore and in order to achieve that similar energy efficiency, but also without sacrificing the accuracy as well. And lastly, I wanted to touch upon the importance of observability, right? And it is similar to everything that we have been doing so far in the IT world, right? Whenever we are building something, it's important that we observe or we monitor that. We need to create the corresponding dashboards with the right metrics, with the right alarms to get notified. And the same applies here. And we have the native observability tool called Amazon CloudWatch, which can help you in monitor this Bedrock metrics. Or if you have certain Bedrock guardrails that you have configured. So guardrails are a way to apply responsible AI into your applications. This would, for example, identifying toxicity or foul language or harmfulness. So these are some of the factors you can configure in the guardrails, and you can basically monitor that in a dashboard and which user and what is the input and output that you're getting, right? So it's really important that you continuously at every stage monitor that. And if you're using more of a SageMaker, then we have the SageMaker profiler and a AWS Neuron monitor to monitor the training metrics and then memory info, the GPU utilization, memory utilization, all that good stuff. And lastly, we have the NVIDIA. So if you're using NVIDIA processors, then you have the system management interface that you can leverage as well. So that's all I wanted to cover today. It's just to give you a few options and to think about how you can build your application sustainably. And we touched upon making use of managed services or serverless services like Bedrock. And the base model selection is also really important. Choose the lightweight models and evaluate it. And if it meets your business use case, you'd always go for that. So you get low cost but also good sustainability into your application. We have the model customization techniques where we touched upon prompt engineering, fine tuning, and RAG approaches that you should consider. And we also talked about the deployment inference optimization, things like model distillation, model compression, and pruning, those kind of stuff. And silicon choice is also really important. So if you've been thinking about training your own models, always recommended to use Trainium for training, which gives you much better price performance and also the energy efficiency that you need. And lastly, the continuous improvement is really, so this is not like a one single journey, right? You build and go away. It's not that the case. You just need to continuously monitor. You will need to change the underlying foundation model. So it's always important to monitor criteria applications. So that's all I wanted to cover today. I hope this session has been useful. And what is a couple of links to the AWS blogs where we talk about how you can sustainably optimize the generative AI workloads and also AI ML workloads in general for sustainability. And you will also see this design considerations and the things that we just discussed in detail in those blogs. So thank you so much for your time. I hope this has been a useful session and have a good rest of the day. Thank you.